We hear all the time about what AI can do. It can compose incredible music, it can help doctors diagnose diseases, but there's one world, a really high stakes world, where all that amazing power just hits a brick wall. And that's the world of steel, concrete, and construction.
It really makes you think, right? If an AI is smart enough to help with our health, why on earth wouldn't we trust it to design a building? Well, the answer to that question reveals this huge crisis of trust, and it's something that challenges the entire future of artificial intelligence.
And boom, there it is. That's the heart of the problem. Think about it. In the software world, if there's a bug, okay, you push an update. But in construction, a bug isn't just a bug, it's a collapse. The stakes aren't just high, the source material calls it catastrophic liability. This is where code meets real-world consequence. And frankly, it's a legal nightmare.
So, to really get why this is such a tough nut to crack, we need to look beyond the AI's raw power. It's not about the AI not being smart enough, not at all. The real issue is something much, much deeper. It's about a profound gap in meaning.
Okay, look at this. This really spells it out. On the left, you've got what's called an iconic sign. It's a 3D shape of a beam. And AI is brilliant at this. It sees the shape and says, yep, that's a beam. Easy. But then look at the right side. That's a symbolic sign. And this is a whole different ballgame. This isn't just a shape anymore. It's a bundle of promises. It's a promise that it can support 5 tons, that it's made of a specific grade of steel, that it meets all the right codes.
And that disconnect right there, that is the central problem. Experts call it the semantic gap. You can think of it like a giant canyon between the thing an AI can see and the responsibilities that thing has to carry in the real world. And right now, that canyon is just way too wide for any AI to jump across. So we have this gap, but how do we actually, measure it? Well, researchers have this really clever framework that works like a ladder. It lets us measure how mature, or you could say how trustworthy, any piece of information really is. It's called Stamper's semiotic ladder, and it starts at the bottom with just raw physical data. Now, today's AI is a rock star at climbing these first few rungs. It finds patterns, it gives them some structure, no problem. But the real climb, the part that actually matters for our problem, is getting to the top. To semantics, what does it all mean? To pragmatics, what's its purpose? And finally, to the very top rung, the social level. That's where responsibility and legal liability live. Now, what's so great about this ladder is that it lets us pinpoint exactly where our current AI systems go wrong. And it turns out when an AI tries to do engineering, there are 2 main ways it can fail. So first up, there's the bottom-up failure. Let's say you scan an existing building with a 3D laser. The AI gets all that raw data. It recognizes the shapes of the beams and columns perfectly. It makes it to level 2 of the ladder. And then it gets stuck. It just stops. It can see the geometry, but it can't abstract that into a real engineering component with real logic behind it. They call this an abstraction failure. And what you're left with is a 3D model that looks absolutely perfect, but it has 0 legal or engineering meaning. It's juridically inert. The source material has this fantastic term for it, a structural hallucination. I love that. It looks real, but it's just an empty digital ghost. The second path to failure is the complete opposite. Here, the AI starts at the top of the ladder. It knows all the rules, all the project requirements. It tries to climb down the ladder to create a design, but it just can't connect those perfect abstract rules to the messy, complicated constraints of the real world. This is called an instantiation failure. The result? You get a design that's completely logical, totally compliant on paper, but it's physically impossible to actually build. It's a perfect theory that's totally useless in reality. Okay, so we've mapped out these 2 roads to failure. The big question now is, how do we build a road to success? Well, the answer isn't just a smarter AI, it's a fundamentally different kind of AI, one that isn't some mysterious black box. This is where it gets really interesting. You have black box models, which are great at finding patterns but can't explain how they did it. That's a total non-starter when liability is on the line. Then you have white box models, which follow rules perfectly but are too rigid to learn anything new. The solution, the sweet spot, is right in the middle, the gray box. It's an approach that's designed specifically for these high-stakes decisions.
This gray box approach has a name, Neuro-Symbolic AI. And it's basically a hybrid. It gets the best of both worlds. It uses neural networks, the same tech that recognizes faces in your photos, to see the physical world, the what. It then connects that to symbolic systems, an AI that thinks in pure logic and rules, to understand the why. This fusion is what finally lets an AI connect the what with the why and finally bridge that dangerous semantic gap.
And by bridging that gap, we're doing so much more than just creating a smarter tool. We're actually laying the foundation for something way more important, an AI that we can finally truly trust, one that we can hold legally accountable for what it does. For an AI to be really accountable, it has to be built on 4 key pillars. Socially, it has to give justifications that actually build our trust. Technically, its work needs to be completely traceable, not just some fuzzy approximation. Legally, it has to be designed so that a human engineer can always stay in control and confidently sign off on the work. And finally, architecturally, it has to be designed for transparency from the ground up.
So, really, what this all comes down to is a necessary evolution. The goal isn't just to make a better 3D modeling program. It's about elevating AI from a simple graphic assistant into a responsible agent. An agent that has what the source calls forensic maturity, meaning its work can be audited, verified, and, if it ever came to it, actually stand up in a court of law. And that leaves us with the ultimate question, doesn't it? The one that this entire challenge is all about. As these AI systems get more and more powerful, we have to ask ourselves, when a fully autonomous AI designs the next great bridge, who's going to be the one to sign the drawings?